In this video, I'm going to work through question 9 through 11 from the 7.5 hydrates practice worksheet. Okay, so let's look at question 9 first. It says a hydrate of aluminum bromide is composed of 71.16% aluminum bromide and 28.84% water. What is the formula for the hydrate? Assume 100 grams for the hydrate. So, if we are given percentages and we are asked to convert, or if we're given percentages and we're asked to find the formula of a compound, the percentages can directly be translated into grams, right? So because it's 100 grams, we can say out of the 100 grams, 71.16 grams is aluminum bromide, and that 28.84 grams is water. Now, the next step is to convert both of these compounds into moles. So remember that if you are given the percentage of just the ionic compound and you are also given the percentage of water, that means the aluminum bromide that you have been given is actually anhydrous because it doesn't say that it's the hydrate, right? So this is the anhydrous ionic compound, and we are trying to find how many water molecules are attached to this aluminum bromide. Okay, and this is the mass of water. It's directly been given to you. So let's convert these into moles. In order to convert this into moles, you actually need to calculate the molar mass of aluminum bromide, which I will do over here. So I have 1 aluminum and 3 bromine. 1 aluminum is 26.98 grams per mole. Oops, 26.98. 26.98 grams per mole. And bromine is 79.90 grams per mole. And we have to times that by 3. Okay, so let's do that over here. This is the first time I'm using the calculator from my computer, guys, so I might have some typing issues here because I'm typing with the pen. Okay, 79.90 times 3 plus 26.98 gives me 266.68 for the molar mass of aluminum bromide. Okay, so 266.68 grams of aluminum bromide under 1 mole of AlBr3 will give us moles of aluminum bromide. Okay, and let me also set up the one for water. 1 mole of water on the top, 18.02 grams of water on the bottom. Okay, that gives us the moles of water. So let's calculate the moles of aluminum bromide. Grams and grams cancel out. So I'm going to do 71.16 divided by 266.68. That gives me 0.2668. Oh, that gave me a lot of decimal places. Okay, so I'm going to say 0.267. Okay, 0.267 moles of aluminum bromide is what I have. Okay, now let's do 28.84 divided by 18.02. That gives me 1.600 moles of water. Okay, so grams and grams cancel out here. All right, now just like empirical formula questions, what we do is we write this as a real hydrate formula. So AlBr3 giant dot, and we don't know what this is, X number of water molecules, okay? And I'm gonna write the moles of aluminum bromide right next to it, 0.267. And I'm going to write the moles of water right next to the water, 1.60. And the next step is to divide both values by the smaller mole value. And the hint is that, let me actually move this just a little inward so that I have space here. The hint is that the ionic compound is always going to be smaller than the water, okay, because it's either equal or smaller than the water, because it's always going to be one of the ionic compound attached to some other number of water molecules, okay. So let's divide 1.60 by 0.267. That gives us 5.99, which you can translate to 6. So we just found the water molecules over here, and that is 6 water molecules. So the last step is to write your answer in the proper hydrate formula method. So AlBr3 6H2O is our final answer for question number 9. Okay, so let's do the next one. Now the next one is kind of set up like how your lab would have gone, or how your lab is set up. So it's actually giving us the sample of hydrate, which has a 17.44 gram mass. So that is actually the hydrate with the water. So this, I'm going to highlight it. This is the hydrate with the water, which means it has to be heated in a crucible to drive off the water of hydration, and the mass that's over here is the one without the water, so that's the anhydrous mass, and that's the mass that's actually going to be converted into moles, okay. So this question kind of guides you through all the steps that you would have to do in order to solve sort of like a lab situation, and also any kind of problem that would have the hydrate given and the anhydrous given, but not the mass of water, okay. I'm going to just give myself a little bit of space here so that I can do each part of this problem separately. So there we go. Alrighty, so let's do number 10. Number 10 is, what is the formula for zinc sulfate? So that's just guiding you through what your hydrate formula will look like. Just the formula for zinc sulfate. So we know that zinc has a +2 charge, and that sulfate has a -2 charge. This is all from your unit for ionic compounds unit. So the formula for zinc sulfate is just Zn parentheses SO4 +2 -2 balance out, and you have the formula for zinc sulfate. Then B asks you, oh, what is the mass of anhydrous zinc sulfate? Anhydrous zinc sulfate is the zinc sulfate that's left over after the water has been driven off by strongly heating the hydrate. So that is just 9.79 grams is the mass of the anhydrous. Mass of anhydrous. Okay, what is the mass of water? Okay, then if you know the mass of the hydrate and you know the mass of the anhydrous, the mass of the water is just the mass of hydrate, which is 17 point, what is it? 44 grams. We know the mass of the anhydrous, which is without water, is 9.79 grams. So mass of water is just basically the subtraction of these two. Mass of H2O is going to be 17.44, 17.44 minus 9.79, 9.79. 7.65 grams of water is what we have. 7.65 grams is the mass of water. Now, once you have done this subtraction, this part is no longer required for calculations, because in order to find the formula of the hydrate, which is part D, all you need is the mass of anhydrous and the mass of water. So let's do D. So mass of zinc sulfate is 9.79. So you have 9.79 grams of zinc sulfate, which we're now going to convert into moles. We want moles of zinc sulfate. And then we have 7.65 grams of water, which we will also convert to moles, just like the previous problem. It's just phrased a little differently, okay? So this is moles of water. So let's find the molar mass of zinc sulfate now. I'm going to use green. So zinc is, let's use this space. Zinc, and then you have one sulfur, and you have four oxygens, okay? That's what sulfate is made of. So zinc, the mass is 65.39 grams per mole. And then sulfur is 32.07 grams per mole. I'm getting these values from the periodic table that you have. And oxygen is 16 grams per mole, but there are four of them. So we got to times that by 4. Okay, so let's find the mass of zinc sulfate. So 16.00 times 4 gives us 64 plus 32.07 plus 65.39. That gives us 161.46. So 161.46 grams per mole is the molar mass of zinc sulfate. So I'm going to put 161.46 grams of zinc sulfate on the bottom here. Let me just scroll up to give myself some writing room, and 1 mole of zinc sulfate over here. And then let's set it up for water as well. 1 mole of H2O over here, 18.02 grams of H2O over here. Then grams of zinc sulfate cancel out. So let's do 9.79 divided by 161.46. That gives me 0.0606. So let's say 0.061. Okay, so 0.061 moles of zinc sulfate. Then I have 7.65 divided by 18.02. That gives me 0.424. 0.4245. So let's do 425. 425 moles of water. Now you see that the moles of water is always larger than the moles of zinc, okay? Every single time that will be true. If you have a mole value for your ionic compound that is larger than your mole value for water, you've gone wrong somewhere. So you have to go back and just check your work, okay? That's a way to check if you're doing the right thing. So zinc sulfate dot X number of water molecules. We have 0.425 moles of water. We have 0.061 moles of zinc. 0.061 is much smaller than 0.425. Oops. So we divide both by 0.061. This is going to just be 1.425 let's just divide that by 0.061. That gives me 6.959. That's actually 6.96, which translates into 7 water molecules. Okay, so let's write the hydrate formula as it should be written. Zinc sulfate, this is this number, giant dot 7H2O. That is our final answer. Okay, so zinc sulfate heptahydrate is the formula's name. Alright, now let's do this question, which is number 11. Pretty much the same thing as number 10. Again, you have been given a hydrate of sodium carbonate, which has a mass of 4.31 grams before heating. So this is with water. Okay, after heating, the anhydrous compound is 3.22. Determine the formula of the hydrate and then write out the name of the hydrate. Okay, so massive anhydrous sodium carbonate is 3.22 grams. So if you have the hydrate and you have the anhydrous, you can find the mass of water. Mass of H2O is going to be the hydrate minus the anhydrous. Okay, this is the anhydrous. Anhydrous. Let me write that up. Anhydrous. Alright. So hydrate is 4.31 grams minus 3.22 grams. 4.31 minus 3.22 equals 1.09 grams of H2O. Okay, the reason I did this first is because I like to set up my mole values or the mole conversions just like I set up for the two previous problems together with the anhydrous and the water in line with each other. Okay, so we're dealing with sodium carbonate, so we have 3.22 grams of sodium carbonate, which we need to now convert into moles. So we end up with moles of Na2CO3, and then we have 1.09 grams of H2O, which we also need to convert into moles. So we end up with moles of H2O. Now let's convert the sodium carbonate. In order to do that, we need to figure out the molar mass of sodium carbonate, which I will calculate over here. So we have sodium, but we need 2 sodiums, and we need 1 carbon and 3 oxygen. So the molar mass of sodium is 23.00 grams per mole. That's times 2. Okay. Carbon is 12.01 grams per mole. And then we have 3 oxygen, so that's going to be 16.00 grams per mole times 3. Okay, so let's calculate that. 16.00 times 3 gives us 48 plus 12.01 plus, I'm going to do parentheses, 23 times 2. Close parentheses, equals 106.01 grams per mole. Alrighty, sodium carbonate's molar mass is 106.01 grams of Na2CO3 under 1 mole of Na2CO3. So that's to convert the 3.22 grams of sodium carbonate into moles. And then over here, 1 mole on the top, 1 mole of H2O. Then the molar mass of water is 18.02 grams on the bottom. Okay, so let's cancel grams and grams. Let's divide 3.22 divided by 106.01. That gives us 0.030 moles of sodium carbonate, and then we have to divide 1.09 by 18.02. That gives us 0.060 moles of water. See, always the moles of water are larger than the moles of your ionic compound. Okay, so let's write this out. Na2CO3 giant dot X number of H2Os. I have 0.060 over here. I have 0.030 divided by the smaller value, 0.030. This is going to be 1.06 divided by 0.03 is going to give us 2 water molecules over there. So the formula of the hydrate is Na2CO3 dot 2 H2O. And the question also asks us to write the name of this formula. So that's going to be sodium carbonate dihydrate. That's the name of the formula. Sodium carbonate dihydrate. Okay.